Well, hi, good morning, and thank you for joining me in my shop. Today I'm going to be replacing a couple more capacitors in this radio, and that should do it for the paper wax capacitors. And then we're going to start checking the alignment a bit and maybe tune the radio up. But first, I want to take a moment and show you what it's like to be on this side of the camera. Of course, I don't normally get in front of the camera, but to be making these videos and putting them on YouTube, you get a lot of emails from, I get a lot of emails from people who want to advertise on my channel. Now, if you've noticed, you've never seen an advertisement on my channel that wasn't a Google ad, just automatic Google ad. I've never agreed to anything, and I've been probably asked, and I could have to guess over the years, probably 300 times, will you please promote my product on your channel? And I've just resisted it. I'm not interested in doing it. I'm not really looking to make money on YouTube. That's really not my goal. A little bit of money is fun, but that's really not my goal. So I'm going to show you just one email. I just got this, I think, yesterday or the day before, and it's just typical of the emails I get. And this would be typical of what's happening with every video maker. And I'm a small operation here compared to other video makers who have millions of followers and stuff like that. They must be swamped by people asking them, can you please promote my product? So here, I'll just show you this one email here. Okay, so this is from a company called Burberry, which I'm not familiar with, and that's regarding like Burberry wants to negotiate ad pricing for your channel. So right away they say, hey, we got money for you. Good evening, I am the head of Burberry. The head of Burberry. We are very interested in your channel. I am Thomas. Have you heard of Burberry, our brand? Actually, I haven't, and I'm not going to promote it right now. We have recently commenced a recent marketing initiative. We are interested in collaborating with you. We are prepared to present you with an attractive proposal. If you are interested in our offer, please get back to this email, and I will provide you with a media kit that includes a promotional video and the contract terms. Now, I have no idea what Burberry does. I have the feeling it's clothing, but I'm really not sure. The emails of this sort that I get, they come from all kinds of companies with all kinds of stuff, and I don't think they have the slightest notion of who I am and what I do on YouTube. They just blast out emails to YouTube video makers and to see who they can hook. Well, they haven't hooked me yet. In fact, there's nothing more annoying to me than watching a YouTube video, similar in production values to mine. It's just a homespun thing, right? There's nothing fancy going on there. I don't have staff in the back working on editing my videos or anything. I got nobody. It's just me. And I love that. I think that's great. Great for me, great for everybody, and great for the world. That individuals like myself who have something to share can do it through YouTube. It's fantastic. But I don't like watching videos where, and there's somebody like me, just an ordinary guy, kind of, and all of a sudden he just switches into hawking some product. And he got the email, and he set up the deal, and he's got a contract with whoever it is he's hawking. And he doesn't care less about that product. He liked the deal. And I think this is a corrupting force on YouTube video makers. And I could talk at length about the challenges of making YouTube videos. Now, I've made sure that my life is kept simple with doing this. I made sure of it. That's one of the reasons I don't read comments. Keep things as simple as possible, or you can get overwhelmed. Now, those video makers who make the semi-professional or professional quality videos, they obviously have staff. Sometimes I think they are just a staff member, and the production really is coming from other people. They're just a voice on YouTube. Wow. Okay, I kind of lost my train of thought there. And you see, on those videos, they would edit that out. You'd never know the guy loses his train of thought. But with me, the train is barely on the tracks. So, hey, coffee time, and then we'll start working on the radio. And just in case you think I don't do anything to try to stay on track, I keep a piece of track in my shop that to help me stay on track. Yeah, this is real train track here. This is actually subway train track. This is the track a subway train would run on. I think it's the same as a rail, a regular big, locomotive type train. There we are. So keep this in my shop. I look at it periodically, and I don't think anything actually. I think, what is that doing in my shop? Okay, now to coffee. Yeah. Okay, so I think we're only left with 2 wax capacitors in here, 1 and 2. And I don't see any others. I don't see anything. Sometimes there's a capacitor up on the antenna. There isn't one here. There's nothing up on top at all. Very good. 2 more to go. Now, what are these guys doing? So, offhand, I don't know, but I'm looking at what pin this one's connected to. The same pin as this. And up here, the other end is connected here, the same as this. And this one's coming over to what looks like a connection to the frame of the capacitor. Connection to the frame of the capacitor and then over to this point. What point is that? So it's on a terminal strip. It's on the floating terminal, and there appears to be quite a few wires connected to it. Look, 22 or 2.2 megohm resistor. That's easy to find on the schematic. So we find this resistor, we find the end of the capacitor. We find both ends. 2.2 megohm resistor, and all this is happening around well, it's around the first IF transformer. That's where the parts are physically located. Let's look on the schematic, see what we can find. Okay, somewhere around the first guy. So C6, C5, C6 and 5. What size are they? Are they wax? Well, 5 and 6. Oh, both of them the same size. 5 and 6, 0.05. Where'd it go? Where'd you go? 5 and 6. 6 and 5. I don't believe I've replaced these. So these are probably the 2 right here. This one is between. What is it between? So here's the B plus line here. Nope. And this is the B minus line coming across here. So one is going to the B minus. And you can see that these 2 capacitors have an end connected together. Hey, there's the resistor hooked in there too. R3. 2.2 megohms. Bingo. Okay, so it all adds up. So these are them. Now, if they're both 5 and 6, they're both the same size, how am I going to tell which is which? Because of where they're connected. So one of them is connected to, wow, I'm going to have trouble tracing all this stuff. I can figure out which one is this. Which one of the 2 in the radio is actually this one. So it'll be connected between, as I said before, B minus and what is this? This is the I find this schematic confusing to look at. I don't know. There's a myriad of things connected here. So okay, let's replace those 2 because I'm going to do them together anyway. It doesn't matter if I try to sort out which one's which. 0.05 in both cases. Eh? Okay, good enough. Good enough. Okay. Now they're out of the way of each other, so I can do them one at a time. I'm going to start with this one here, and it's connected to the same terminal as the other one. So I can't get that wrong. Well, it would take some effort to get that wrong. We'll cut it out of here. .05. Let's give him a test. Boy, this clip lead's just hanging by one, I think just one strand of wire at this point. It's not going to last much longer. Okay. Okay, watching the pie on the eye. Here we go. 50 volts. Opened right up nicely. 150. Can't do it. Definitely leaky to some degree. Obviously not as bad as it could be. And the other one. At this point I'm going to put in the clip lead. He jumped right out of the radio. There he is. 0.05. Yep. 0.05. Let's give him a try. All in all, the capacitors in this radio have ranked, I would say, better than average for such an old radio. Probably means the radio's been kept in fairly good, probably kept indoors its entire life. There we go. Maybe in an air-conditioned house much of the time or something. Here we go. 50. Open right up nicely. 150. Opening up pretty good. Okay, how about 250? Oh my gosh, still opening. So this guy's really quite serviceable. I could have left him in the radio, but how do you know? You don't know unless you take it out and test it. And it's only going in one direction, and that's downwards anyway. And I wouldn't want to leave him behind. If I left him behind, he might be all upset about it. You know, why me, all that kind of stuff. And now I went and I cut the capacitor free, and I did not clip it. And boy, oh boy. I look back at the radio, I got no idea where it was. That's where it was. Okay, so we're going to put in a couple of .05s in there. And then we're going to operate the radio. Okay, I've got the two capacitors installed. Very good. Okie dokie. That's it for the wax capacitors. The rest of the capacitors, there's more in here. Mica type capacitors generally don't cause trouble, but there's no guarantee that they aren't defective. It's just very, very uncommon. In fact, it's very uncommon that I have to deal with one of those guys. So what we're going to do now is turn on the radio, make sure it's still operating. And then we're going to look at doing alignment on it. I don't think there's any need for it to be up like this anymore. Okay. There we are. How well do you work? Now first we're going to try this on its internal antenna, its built-in antenna, the AM antenna back here with no help from any other antenna. Okay, so we're on. Here we go. Let me just turn down my lights here a bit. So the dim bulb on here is so barely lit. You can barely make out the filament in the camera there. Because I do have this on restricted voltage, 100 volts right now coming to the radio. Okay, let's go the whole shooting match. So this light is still extremely dull. Either they've put the wrong kind of bulb in here, or a lot of these lights, panel lights that are run from heaters, from heater taps on rectifiers, don't get very bright. Where's the sound? Here we are. Okay, we're on the broadcast band. The pointer is up here, but in fact the capacitor is close, almost closed. Hey, where'd it go? Nobody? So the buzz you're hearing is not the radio, it's interference in my shop. What is going on now? Just so you know what's going on with me, because you need to know these things. Like, I'm wearing rubber-soled slippers here. I'm standing on a rubber-back mat on top of tile on a concrete floor, stuck on the earth. I am not in any way grounded. There's a piece of wood. That's very interesting. And wherever my bench has been, worked on here, this work area, has it become conductive? Now what I'm going to do next is crazy. But I have a desk. I have a corner desk in another room that I use. It has my radios all over it, and it's a corner desk, one of those classic desks you buy for your kid in high school. It has a black surface on it. It's completely conductive. If you take an ohm meter like I'm about to do and just touch it, you get a reading. And you'd think it's impossible to be conductive, but it is conductive. And I think this surface is impossible to be conductive. At least on this kind of test. Well, let's see, because stranger things have happened, have they? I'm on the 60 megaohm. What was that momentary thing there? I don't think. Can you see what I'm doing? Pretty close. So this is a point contact, and my hand is a big contact. Don't tell my wife I did this, okay? She'll lose faith in me. No, nothing there. So what exactly is going on when I put my hands on the bench? I don't know. Underneath it is, well, you can see the light I've got going. I've got one of those strip lights under here. That didn't help. I don't know. Okay, enough of that. Radio's operating. So what we're going to do next is we're going to stop leaning on the bench. Don't lean on the bench, Jim. We're going to run through both the broadcast band and the shortwave band in particular. We're just going to assess how well the radio is working. And I'm going to leave it running here. while I go and drink a little more coffee. Then we'll do the test. Weird stuff. Okay, let's give this radio performance test. Now it's tuned into something. You have to pretend that that interference isn't there. It's me again. I put my hands down. Don't put your hands down, Tim. Okay. Okay, I think that's right on. Antenna direction. About like that. About the strongest signal. Now, I have an outdoor antenna. This is the hot lead from the outdoor antenna. I'm gonna clip it onto here.
Trump's lawyers made the case that even the appearance of wrongdoing should be enough to get Willis taken off the case.
So the string is slipping terribly here. Okay, now we're going to attach the ground and see what happens with that. So when I connected it to the frame of the capacitor, you probably heard a low, intermodulation interference or intermodulation distortion. Probably there's a large AC voltage between the frame and here. And why I say probably when you can measure it. And I may have, by doing that, I may have put my antenna at risk. It doesn't seem to have hurt it though. So we're looking for some kind of, say, AC voltage, line voltage. This is just a ground on an antenna lead going out to an antenna, but it's grounded in various places. Yeah, so there's 50 volts there. So 50 volts is roughly half of 100. Well, actually, it's exactly half of 100. So what you're seeing here is the effect. Oh, leave that on. The effect of I don't know how to explain it. I don't know how to explain it. Okay, we're going to clip this on here. I'm not going to explain it. There's no place to clip it. I think that's the best arrangement all around. Okay, let's see how loud is it?
City News Time, 9:21.
Good strong antenna, lots of volume. Get your hand off the table, Jim. Now, we're going to tune down. We're going to try. We're going to do it this way. There are lots of stations going by there. So we're at the 500 end, regardless of what it says. $860. And up high, it's only one station. You might get 1430 way up here. You probably won't hear it. Yeah, you're not going to hear it. Okay, so that performance, even despite all the noise in that, actually was okay. That was okay, given the situation here. So let's now try the shortwave band, which I have not listened to on this radio, I think, since the start. The antenna I have connected is quite suitable for shortwave. The pointer is down here, so in fact we are tuned at this end for up at 14 megahertz, and the capacitor is wide open. Do we pick up any shortwave? Nice hiss, but there's a hum in there with it. The volume's up pretty high though. Here we go. Well, it didn't take long. Same station in it, coming in again. That sounds like ham radio guys fooling around. So, yeah, volume's about halfway. Oops, I changed direction here.
Now, in its mate, this solemnity of this time, how it is saturated with such pollution.
Yeah, I agree.
Wild.
Okay, keep going. Something is saturated with pollution. What do you think he was talking about? Now the pointer's here. Well, we're really tuning up here, coming this way. So we're up around, I would say, 12 megahertz. It's in a band 11.4 to 11.8 or something like that. We should be going through. So that's teletype. Could be teletype out to a ship even. Who knows what it is. There's more teletype. That's not teletype. You have to tune this radio very slowly, or you go right past the stations. So by now we're probably down around 10 megahertz, so WWV is possible, and this is probably Radio Marti, or it could be Radio Cuba. Just judging by the language and the... Am I turning anything here? I'm not turning... Oh! Yeah, this string is not working here. There it goes.
Temprano. Despertó en Iraida sus dos pasiones, la política como ciencia, especialidad de la que se graduó en la Universidad de Nueva York, y la poesía, de la que se ha ido grabando en cada verso, en cada poema, en cada libro publicado.
That's Spanish, I think.
Fundado revistas literarias.
Okay, carrying carrying on. So we're getting down into the lower frequencies now. At this time of day, there's not much action. So we're here, so we're probably coming into here. I'm not sure. It's a very, very powerful station at 9.33, if it's operating. It should be right there.
First Timothy chapter 1, verse 17. Listen to the language Paul uses time and time again. Romans. Now First Timothy 1.
Okay, carrying on.
Who is wise? The honor and glory forever and ever. Amen.
So that could be an image
And those
of the other signal, or vice versa. Okay, picking up the same signal in two places, but it's only broadcasting in one, I'm pretty sure. And from here down, we probably won't hear a thing. Just some noises. Oh, bingo. This is probably CHU from Ottawa, Canada. Check your clock. You see the second hand? You can't. The second hand is down here at 6. Oops. Don't know how to work my watch anymore. It's too complicated. We're just waiting for the station identification, which will come in just a moment. Here it comes.
CHU, Canada. Coordinated Universal Time. 14 hours. 6 minutes.
I gotta tell you, man, my wife got me this watch for Christmas. This is one of those expensive Apple watches or whatever. And don't ask me what time it is anymore, because I have to find out what time it is. Well, okay, we still got a little further to go. So that is CHU Canada. This would be 7.333 or 330 or something like that. It changed frequency. I think it's on 3 frequencies. Okay, we're going to move on. I'd just be really surprised if we pick anything up here. At night, this would be more active. Down to the bottom. Okay, so that was a review of the performance of the radio as it stands right now, after having done the electronic work, if we can call it that. And now it's time to tune the radio up by doing an alignment on it. So I really want to go through and just see how well it's working before I start making adjustments, because I want to know if I'm improving things or not. So next thing to check is the intermediate frequency tuning, and make sure that's correct. That's probably the last thing we'll do today. And before I do that, I'm going to give a quick explanation of how the radio operates, so you can follow along as to what it is exactly I'm trying to do. So, but coffee break first. Okay, just before I get going, I'm going to assume you're not familiar with the secret of the super heterodyne radio. This is a super heterodyne radio. All radios pretty well are. After about 1929 or 1930, somewhere in there, there was a huge advance in radio technology made when this technique was discovered, the super heterodyne. Heterodyne talks about the effect of mixing two signals. If you take two signals of two different frequencies and mix them together, you'll end up with 4 frequencies. You end up with the 2 original. You'll end up with one which is the difference between the two frequencies, and you'll end up with one that is the sum of the two frequencies. So you get four signals. Put in 2, get out 4, if you can mix them. Why am I talking about this? That's what's going on in this radio. So this radio has its own little transmitter in it. It doesn't actually transmit anywhere, it's just contained in the radio. And it's called the local oscillator. Local oscillator. And now, I'm going to get a better pencil because the lead is broken on that one. Let's try this one. Again, I'm going to keep this as simple as I can and break the radio into a couple of parts here. So first part is the antenna. Next part is the converter. Next part is the IF amplifier. The last part, well, next part is the detector. And then the last part is the audio amp. And at the very end of it is the speaker. There we are. And put the antenna up here. There's one more box missing. Remember I said there was a transmitter inside the radio called a local oscillator. I'm going to draw that down here. Local oscillator. When you tune the radio, you're actually changing the frequency of the local oscillator. That's what you're actually doing. Now, you could be doing a little more. You could be tuning some stuff in here. But the primary thing you're doing in a super heterodyne radio is you're varying the frequency of the local oscillator. So just imagine for a minute we're tuned to a station. Let's say it's 860. 860 here, 860 AM, is the frequency that the CBC broadcasts on AM radio in French that I can receive here. So you got the radio tuned to 860. There's probably some circuits in here which are also now tuned to 860. Kind of broadly though. Kind of broadly tuned to 860. In a way, you're tuning the antenna to the station you want. At the same time, you're varying the frequency of the local oscillator as you're turning the knob. When you get to 860, and you can hear 860 coming out, all things being correct, the local oscillator is running at 860 kilohertz plus, in this radio, 456 kilohertz. The actual local oscillator frequency then has to be 6, 1, 12, 13, 16. So what's happening is you're generating a frequency here of 1360. It's 1316 kilohertz. If I did the math wrong, just ignore my arithmetic errors. It's the idea I'm trying to get across. Okay, so there's also a so I'll take that back. So this frequency is being generated by the local oscillator. It's being fed into this converter. At the same time, the antenna frequency of 860 is being fed into the converter. And what's coming out is the 4 products. So out is coming 860 again. Out is coming the local oscillator at 1316. Out is coming the sum of these two frequencies, 1316 and 860 is 20, 21, whatever it is, 21 something. And the difference frequency. The difference frequency between 860 and 1316 is 456 kilohertz. Those 4 frequencies. The rest of the radio is tuned to one of those 4 frequencies. It's tuned to this one, 456. So if you present the IF amplifier with a frequency of 456 kilohertz, it goes through the radio, it gets detected, and comes out the speaker. Everything else is rejected. So tuned to 860, actually setting the local oscillator 456 kilohertz above that at 1316. Mixing that stuff together produces a 456 kilohertz signal that's the radio is sensitive to. It can hear that. Through it goes. The thing to keep in mind is that this conversion isn't only happening on 860. It's converting the entire antenna signal. So, in a way, you're shifting the frequencies that are coming on the antenna. You're shifting them 456 kilohertz. And as you vary this frequency, you're shifting the entire band of stations. And if at any time, any combination produces a 456 kilohertz signal through the radio and out the speaker, that's really what's going on. Varying the local oscillator, mixing different frequencies to produce this, which is going to go through the radio. The radio can only hear this frequency here, the local oscillator frequency. What happens? These radios, they can be tuned incorrectly. So maybe this part is not sensitive to 456, but is now sensitive to 470. So what happened then? Basically, dial in accuracy on the radio. When you tune the radio to receive 860, the dial will tell you you're not at 860, you're at 900 or something like that. So it's very important to get the local oscillator on the correct frequency, which is part of the alignment game. And the other part is to make sure the IF is tuned to the intended frequency, 456, for this radio. How do I know it's 456? I read it on the schematic. Most radios are 455. 456, 455, not a lot of difference. So now we have a radio in front of us, and we're going to ask some questions. What is the local oscillator frequency? Is it really 456? And what is 456 away from the tuned station? And is the IF tuned to 456 as it should be, or is it drifted off, tuned to something else? We're going to start with that second one. The way we're going to do that is we're going to turn on this signal generator. I'm going to set that to the IF frequency, 456 kilohertz, the frequency that the radio is sensitive to. We're going to feed it in right at the antenna. It's going to work its way through here and show up in the speaker. And we'll find out, is it really 456 or is it something else? Chances are it's very close to 456. So this is the frequency my signal generator is running at right now, which is way off from where we want it, which is okay. I'm going to take the output of the signal generator and I'm going to connect it where the antenna is right now. Okay, and connect the ground like that. Now I set this down to 456 kilohertz. We should hear something come out of the speaker. What will we hear? We hear a tone coming from this. The tone is set to 400. The tone is set to 1,000 hertz. Signal coming out of this is, let me check the calibration on it, way low. There we are, it's better calibrated now. So the signal coming out is around 1,000 microvolts. A little bit low. Okay, so we'll now adjust the frequency down to 455 here. There we go. Listening. Make sure the volume's up on the radio. Oh, it's really a hummer. Here we go. And nothing comes to reply. Okay, so not enough juice. More juice. Go back up. More volume. Okay, so 444, not 456. Let's just go hunting. So this is tricky business now. My signal generator produces harmonics. The harmonics can be picked up by the radio like a radio station. So even though I've got the signal generator set at the IF frequency, there's probably a 900 kilohertz signal coming out. If you remember, I think I left the radio tuned near 860. Let's tune the radio and just see. If it's the IF, no difference. If it's the radio picking up a harmonic, it will go away. It went away. So we can ignore that. That's the same one. That's probably another one. Yeah. So you don't want these things to confuse you. Let's go back to the 4. I thought it was 444. Let's tune it. Huh. So we're not actually triggering the IF yet. Should be the case that the tone comes out and it doesn't matter what tuning I do, it stays. So I'm going to boost this up. Now we're pumping in a very, very strong signal. Now we'll tune the radio. So right now we hear nothing. Let's tune this. That's the frequency we're supposed to hear, 455 or so. Some weird stuff going on there. We'll tune the radio and see what happens. It disappeared. Something weird about this. There it is down there again. But if I tune the radio, it goes away. So we're not able to inject at this point the frequency I want to inject into this radio and know for sure we found it. It's a little odd. That's a little odd. Is I doing something wrong here? I don't think so. Let's, you know what I can do? I'll put this on shortwave. It is on shortwave. Oh. I'm more clever than I realized. I'll put this on broadcast. How's that going to help? Don't know. Okay, let's try again. Get my hand off the bench here. That's a lot better. That was a lot better. That, I'm pretty sure, is the yeah. Okay, we'll tune it where we think it's the strongest. We'll tune the radio. It stays. Okay, so we are now hearing the IF. In other words, I'm pumping a signal in here at the frequency that the IF amplifier is sensitive to, 455. And I'm just pushing it basically through the radio. It's really not supposed to pick up this frequency, but I'm ramming in a pretty strong signal. It's making its way through everything and showing up here. It's one of the 4 coming out of here. And it's not just 4, as you now know, it's 40. Many more than that even. My experience with these things, because the radio only hears one frequency, we're not normally sensitive to all the stuff that's coming out of the converter, because the radio only lets us hear one thing. But I think there's a whole pile of stuff coming out of this converter, and I think in some cases it even kind of, I hate to say this because, wow, kind of loops around in there a bit. It's not really what it does, but you can end up with all kinds of stuff coming out of here. But the radio will only hear the 456 in this case, or 468 is what we ended up with here. 468. Now let's check this very carefully. Again, just doing it by ear right now. I would say it's at 465. That would be my assessment there, just based on listening. Okay, if we're going to do any more to the radio, we need more instrumentation on it. I think maybe we can get away with aligning the IF here today. So break time for me, and then when I come back, which will be just an instant for you, we will align the IF of this radio. Okay, I think we're ready to start. Now, the proper frequency for this radio is 456 kilohertz. How do I know that? Because it says on the other, there it is, 456 kilohertz. I mean, how could I miss that? Why not 455? There is reasoning behind this, but I won't go into it. It has to do with the image and trying to make the radio as insensitive to images as possible. That's the reason for it. On the broadcast band. Okay, so I have a voltmeter connected to the speaker. So if we turn the volume down, the voltmeter goes down, we turn it up. So the objective here is to make adjustments. These two transformers, and tune the primary and the secondary of each one, and boost the signal, knowing that it's the proper 456. Now it's not right now, it's 465. Question, can we get this down and still hear it? So I'm going to go down in frequency, and go down a little further. You can still hear it. If I can turn it up, okay, we can hear it quite clearly. I'm blasting a heck of a signal into it. So now we're going to try to make this meter go up. Inside the IF can are screws. Now those are trimmer capacitors. Some of these cans you are actually tuning a slug. A different deal. It's my lazy tripod. Okay, we're going to start on. We're supposed to start on the second one first, so we will do that. Often these screws are stuck, and it takes a bit to get them loose. Let's see. There it goes. You're watching the meter. There we are. I'll do the other one. Okay, we can cut back the strength here. Do those two over again. Less signal strength being sent into the radio here. Here we go. Generally, you don't want to trigger the AVC in the radio, automatic volume control, because it makes it much more difficult to do the alignment. But you know, if you're careful. Okay, now we'll go to the next transformer. This is actually the first one. One. So that's a pretty good boost in the radio's performance, just doing that. We'll also have set the frequency to 456 here, and this gives the dial a chance to be accurate, except the dial is completely backwards on this radio because the string is in wrong, which is something I'm going to have to deal with. You know, I think I have to deal with that next, because after doing the IF adjustment that I've just done, all the rest of the alignment is dependent upon the pointer position on the dial, and it's completely backwards here. So what that means for me is tomorrow is string day, and I'm going to redo the string here, try to do it properly, and get everything turning the right way. I understand what happened here. The fellow worked really hard, probably broke his brain putting this string together, and when he finally got it to work, he then discovered that he'd done it in such a way that the capacitor is going in the wrong direction. And he probably just put his hands up and went, that's it. That's probably what happened. You just accept that the dial turns the wrong way, but it's more than that. It's not just that the pointer's going in the wrong way, it's that the pointer has nothing to do with the position of the capacitor. So there's no way to read the frequency off the dial of this radio at all. It's completely backwards. Okay, enough said. Let's cut them off. And this is, I have to really think hard to remember to turn that meter off. Okay, well, thanks a lot for watching, and tomorrow we will do the string. That's probably all I will do tomorrow. I'll try not to lose my religion over it, and then it's the final alignment after that. Thanks a lot for watching, and I'll see you in the next video. Actually, I never see you.